It is not recommended to use two generators into one transfer switch for several reasons. Firstly, overloading may occur. The transfer switch would be handling the combined wattage of both generators, which could exceed its capacity and cause damage. Secondly, phase misalignment may be an issue. Generators can produce different phases, and if they are not properly synchronized, it can damage appliances and equipment. Thirdly, safety hazards could arise. If the transfer switch fails, power could be inadvertently fed back into the utility grid, creating a safety hazard. To safely and effectively use both generators, you will need two separate transfer switches. Each transfer switch will be connected to one generator and will provide power to a designated area. For wiring configuration, install a 5500 watt transfer switch for the downstairs and connect it to the smaller generator. Install a 7500 watt transfer switch for the upstairs and connect it to the larger generator. Run separate electrical panels for the downstairs and upstairs areas, with each panel connected to the corresponding transfer switch. Ensure that the electrical system is properly designed and inspected to handle the combined load of both generators. The benefits of using two transfer switches are several. Safety is increased because this eliminates the potential for overloading or phase misalignment. Flexibility is gained because it allows for independent control of power to different areas of the house. Efficiency is maximized because this ensures that each generator is used to its full capacity, reducing wasted energy. When working with electrical systems and generators, it is always best to consult with a qualified electrician to ensure that the installation is safe and meets all applicable codes and regulations. A generator transfer switch is an electrical panel that allows you to safely switch between utility power and generator power. It is designed to prevent backfeeding, which is when generator power flows back into the utility grid, creating a dangerous situation for utility workers. There are two main types of transfer switches, manual and automatic. A manual transfer switch requires you to manually switch between utility power and generator power. An automatic transfer switch automatically switches to generator power when it detects a power outage. When selecting a transfer switch, it is important to consider the size of your generator and the amount of power you need to run your home or business. You should also choose a transfer switch that is UL listed and meets all applicable codes and regulations. Here are some of the key factors to consider when choosing a generator transfer switch. Firstly, the size of your generator. The transfer switch must be rated for the output of your generator. If the transfer switch is not rated for the output of your generator, it could be damaged. Secondly, the amount of power you need. The transfer switch must be able to handle the amount of power you need to run your home or business. If the transfer switch is not able to handle the amount of power you need, you will not be able to run all of your appliances and equipment. Thirdly, UL listing. The transfer switch should be UL listed. This means that it has been tested and certified to meet safety standards. Fourthly, applicable codes and regulations. The transfer switch must meet all applicable codes and regulations. This will ensure that the installation is safe and legal. Here are some additional things to keep in mind when installing a generator transfer switch. Firstly, hire a qualified electrician. It is important to hire a qualified electrician to install the transfer switch. This will ensure that the installation is done safely and correctly. Secondly, follow the manufacturer's instructions. Be sure to follow the manufacturer's instructions carefully when installing the transfer switch. Thirdly, test the transfer switch. Once the transfer switch is installed, be sure to test it to make sure that it is working properly. The basic working principle of a transfer switch lies in its ability to safely disconnect a load from one power source and connect it to another. In the context of generators, it does this by isolating the house electrical system from the utility grid before connecting it to the generator. This prevents backfeeding, a dangerous condition where generator power is sent back into the utility grid. A manual transfer switch typically uses a series of switches or a lever to manually disconnect the utility power and connect the generator. An automatic transfer switch uses sensors to detect a power outage and automatically switch to generator power. The switch consists of several key components, including a switching mechanism, which is the physical component that makes or breaks the electrical connections. This can be a set of contacts, a lever, or an automated switching device. Secondly, a control circuit, which is an electronic circuit that monitors the power supply and controls the switching mechanism in automatic transfer switches. Thirdly, a protective device like circuit breakers or fuses to protect the transfer switch and connected equipment from overloads and short circuits. The installation process typically involves these steps. Firstly, disconnecting the main power supply to the house at the main breaker. Secondly, wiring the transfer switch into the electrical panel, connecting it to both the utility power and the generator. Thirdly, connecting the circuits that you want to power with the generator to the transfer switch. Fourthly, testing the transfer switch to ensure that it is working properly. There are several types of generator transfer switches. Firstly, manual transfer switches, which require manual operation to switch between utility and generator power. These are typically less expensive, but require someone to be present to operate the switch. Secondly, automatic transfer switches, which automatically switch to generator power when a power outage is detected. These are more convenient but also more expensive. Thirdly, whole house transfer switches, which transfer all circuits in the house to generator power. These require a larger generator and a more complex transfer switch. Fourthly, selected circuit transfer switches, which only transfer selected circuits to generator power. These are more economical and can be used with a smaller generator. Transfer switches are essential for the safe and reliable use of generators as backup power sources. They prevent dangerous backfeeding, ensure a smooth transition between power sources, and protect your home's electrical system. When selecting and installing a transfer switch, it is important to consider your specific needs, consult with a qualified electrician, and follow all applicable codes and regulations. For a 7,000 square foot house, consider the load requirements of both the upstairs and downstairs areas separately. A 5,500 watt generator provides 5,500 watts/120 volts, approximately 45.83 amps at 120 volts, or 5,500 watts/240 volts, approximately 22.92 amps at 240 volts. A 7,500 watt generator provides 7,500 watts/120 volts, approximately 62.5 amps at 120 volts, or 7,500 watts/240 volts, approximately 31.25 amps at 240 volts. Ensure that the transfer switches and wiring are appropriately sized for these currents. Standard wire gauges and their ampacities based on NEC table 310.16 are as follows. 14 gauge copper wire is typically rated for 15 amps, 12 gauge copper wire is typically rated for 20 amps, 10 gauge copper wire is typically rated for 30 amps. These ampacities are for typical residential wiring conditions. Always consult the NEC or a qualified electrician for specific applications. The choice between using one or two generators depends on several factors, including the total power demand of the house, the capacity of each generator, and the ability to isolate circuits. If the total power demand exceeds the capacity of a single generator, or if you want to ensure redundancy, using two generators is a viable option. Using two separate transfer switches, as recommended, allows for greater control and isolation of the electrical loads. It is crucial to balance the load between the two generators to prevent overloading either one. Also, ensure that the electrical system is designed to handle the combined load of both generators if they are running simultaneously. When dealing with generators and transfer switches, it is essential to understand and adhere to all applicable electrical codes and safety regulations. These codes are designed to protect people and property from electrical hazards. Always consult with a qualified electrician to ensure that the installation is safe, compliant, and meets your specific needs. The NEC provides comprehensive guidelines for the installation of generators and transfer switches. Some relevant sections include Article 700 covering emergency systems, Article 701 covering legally required standby systems, and Article 702 covering optional standby systems. These articles address issues such as wiring methods, overcurrent protection, and grounding. Proper grounding is essential for the safe operation of generators and transfer switches. The grounding system should be designed to minimize the risk of electric shock and to provide a path for fault current to flow back to the source, causing the overcurrent protection device to trip. Ensure that the grounding electrode system is properly installed and connected to the generator and transfer switch. Regular maintenance is essential for ensuring the reliable operation of generators and transfer switches. This includes inspecting the generator for any signs of damage, checking the oil and coolant levels, and testing the transfer switch to ensure that it is functioning properly. It is also important to keep the area around the generator and transfer switch clean and free of debris. There are a few common mistakes to avoid when installing and using generators and transfer switches. Firstly, overloading the generator. Exceeding the generator's capacity can damage the generator and the connected equipment. Secondly, improper grounding. An improperly grounded generator can create a serious safety hazard. Thirdly, neglecting maintenance. Regular maintenance is essential for ensuring the reliable operation of the generator and transfer switch. Automatic transfer switches offer several advantages over manual transfer switches. Firstly, automatic operation. Automatic transfer switches automatically switch to generator power when a power outage is detected, providing seamless backup power. Secondly, faster response time. Automatic transfer switches can switch to generator power in a matter of seconds, minimizing disruption to your home or business. Thirdly, increased safety. Automatic transfer switches eliminate the risk of human error, reducing the potential for accidents. When sizing a generator for your home, it is important to consider the total power demand of all the appliances and equipment that you want to run during a power outage. Create a list of all the items you want to power, and then add up the wattage requirements. It is also important to consider the starting wattage of certain appliances, such as air conditioners and refrigerators, which may require significantly more power to start than to run continuously. The wattage requirements of appliances can typically be found on the appliance's nameplate or in the owner's manual. As a general guideline, a typical home may require between 5,000 and 10,000 watts of generator power. However, this can vary depending on the size of the home and the number of appliances. It is always best to overestimate your power needs to ensure that you have enough power to run everything you need. The installation of a transfer switch typically involves these steps. Firstly, planning the installation. Determine the location of the transfer switch and the wiring route. Secondly, disconnecting the power. Turn off the main breaker to disconnect power to the electrical panel. Thirdly, mounting the transfer switch. Securely mount the transfer switch to a wall or other suitable surface. Fourthly, wiring the transfer switch. Connect the transfer switch to the electrical panel, the generator, and the circuits you want to power. Fifthly, testing the transfer switch. Test the transfer switch to ensure that it is working properly. The cost of a transfer switch can vary depending on the type of switch, its capacity, and the complexity of the installation. Manual transfer switches are typically less expensive than automatic transfer switches. Whole house transfer switches are typically more expensive than selected circuit transfer switches. The cost of installation can also vary depending on the electrician's labor rates and the complexity of the wiring. As a general guideline, the cost of a transfer switch and installation can range from several $100s to several $1,000s. It is always best to get quotes from multiple electricians to compare prices. Ensure that the transfer switches are properly labeled to indicate their function and the circuits they control. This will help prevent confusion during a power outage. Consider installing surge protection devices to protect your appliances and equipment from voltage spikes. Surge protection devices can be installed at the transfer switch or at individual outlets. Keep the area around the transfer switch clear of obstructions to allow for easy access and maintenance. During a power outage, follow these steps to use the generator and transfer switch. Firstly, start the generator. Follow the manufacturer's instructions to start the generator. Secondly, switch to generator power. Use the transfer switch to switch from utility power to generator power. Thirdly, monitor the generator. Monitor the generator to ensure that it is running properly and not overloaded. Fourthly, conserve energy. Use energy-efficient appliances and equipment to conserve generator power.